We are moving on to Unit 9. This is Unit 9, Lesson 1. We're talking about multiplication properties of exponents. And your objective is to use the properties of exponents to multiply exponential expressions. Alright, let's go ahead and get started. Okay, the first property is called the product of powers property. And basically what that means is to multiply powers having the same base, you add the exponents. So we're saying that we're taking the same base and multiplying them. We take these exponents and add them together. And here's why. Okay, 3 squared times 3 to the 7th. Well, 3 squared is 3 times 3. And if we multiply that by 3 to the 7th, that's times 7 more 3's. 3, 3, 3, and then 4 more. And if we counted up all those 3's, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So what we're doing is just adding these exponents together. So it's 3 to the 2 plus 7th power, or 3 to the 9th. Okay, now for the purpose of your assignment, when it tells you to write it in exponential form, then we're going to leave it like this. If it said to simplify it, then I would want you to figure out what is 3 to the 9th power for your final answer. Okay, but for exponential form, if we want to rewrite it in exponential form, we leave it as 3 to the 9th. Likewise, this one, we're taking the same base, x, and multiplying them together. So it's going to be x to the negative 2 plus 5 power, which is x to the 3rd. Okay, let's go on to the next property. Okay, this property is called the power of a power property, and it's to find the power of a power, you multiply the exponents. So basically what this means is I'm taking a power, so this base to this power, and I'm raising it to another power. Okay, when it looks like this, then I multiply the exponents together. And here's why. Okay, so for example, 5 squared to the 4th power. What that means is 5 squared times 5 squared times 5 squared times 5 squared. Okay? Because we're taking the 5 squared and raising it to the power 4 times. We're multiplying it together 4 times. Well, of course, 5 squared means 5 times 5, and we're multiplying that times 5 squared, which is 5 times 5, times 5 squared, which is 5 times 5, times 5 squared, which is 5 times 5. So that is 8 total 5's. So basically, when it looks like this, what we're going to do is just take 5 and multiply the exponents. So the base stays the same, and we're going to take it to the 2 times 4 power, which is 5 to the 8th. Okay? Likewise, the next one. This is what a power of a power looks like. So we're just going to essentially keep the base the same and multiply the 2 exponents. So I'm going to take it to the negative 2 times 4 power, and that is x to the negative 8th. Okay, now in the next lesson we're going to talk about negative exponents and how to change those, but for this lesson, if you get one to the negative power, it's fine to leave it like that. Okay, and we'll go on to the last property. Okay, and the last property is called the power of a product property. And that means to find the power of a product, so find the power of things we're multiplying together. We're going to find the power of each factor and multiply them. Okay, so basically what I'm saying is if there's something I can multiply together and raise it to a power, then I'm going to put each of those things with the power that I have on the outside. Alright, so for example, 2 times 3 to the 6th power, instead of just saying that this is 6 to the 6th power, we can say that's the same as taking 2 to the 6th times 3 to the 6th. Okay, now again, exponential form, this is my answer right here. It's 2 to the 6th times 3 to the 6th. And the reason why that's important to know is because we want to simplify these things and we have variables involved. Okay, we need to know how this applies with our variables. So 2 times x to the 7th power is the same as 2 to the 7th times x to the 7th. Okay, and that's how that one works. So let's go ahead and see another example of this. If I did something like 12 to the 5th power, I could rewrite that, and 12 could be any number of things, but let's say I rewrote 12 as 3 times 4 to the 5th power. Okay, so 12 to the 5th power is the same as 3 to the 5th times 4 to the 5th. Okay, those are the same thing. And that knowledge is going to be key in some of the upcoming lessons. Alright, now let's go on to some examples where we take all these properties and combine them together into different problems. Okay, our first example up here is negative 3 to the 3rd power and squared. So this is the power of a power. So remember, this is the one where we take the base and we multiply the exponents. So I'm going to take negative 3 to the 3 times 2 power, which is negative 3 to the 6th power. And again, that's how I write it in exponential form, if that's what the directions say. If it said to simplify all the way, then I would want to multiply that all out. Alright, now this one. This is still a power of a power. This is my base, and I'm raising it to a power, and then to another power. This isn't like the third one because we're not multiplying these things. So basically, my base is a plus 1, and I'm going to multiply the exponents together. So it's a plus 1 to the 10th power. And now again, if I was taking a times 1, then it would be a to the 10th and 1 to the 10th. Okay, but because it's adding, we don't do that on this one. Alright, now this one right here, this one we can use the first one that we used. Okay, the product of powers property. But the only catch is that these bases aren't exactly the same. But I could rewrite the problem so I have x as my base. And I could do that by saying this first number is going to say the same. This is x to the negative 2nd. And we're multiplying that. Instead of saying negative x to the 5th, I could make that negative 1 times x to the 5th power. So I'm taking x to the negative 2nd times negative 1 times x to the 5th power. Now I've got two parts out of the same base. So that's where I add the exponents together. So this negative 1 I'm just going to put out in front times, and it's x to the negative 2 plus 5, which is third. Okay, so I can write it like that, or I can say that's negative x to the 3rd power. Again, the reason we were able to do that is because this is the same as negative 1 times this power. And we can do that because this isn't in parentheses. Alright, and let's do the last example on this page here. This one is really tricky. Notice here, we've got a bunch of stuff in here raised to a power. So basically, all this stuff, if I wanted to rewrite this, we need to recognize that all this stuff is being multiplied together. So this is negative 2 times x squared times y. So I'm going to rewrite that just for the sake of the lesson and realizing what this actually means. That's all to the 4th power. And we're going to multiply that. Out in front here, this says negative, so that's like negative 1 times, this is 2 times x squared times y to the 4th power. Okay? Well, when we were multiplying things in the parentheses, remember, we apply the exponent to each one of these. So really, this looks like this. It's negative 2 to the 4th power times x squared to the 4th power times y to the 4th power times, we got our negative 1 there, and then everything in these parentheses the exponent applies to. So it's times 2 to the 4th power times x squared to the 4th power times y to the 4th power. So now anything with the same base I can combine together. So like, well actually sorry, first we need to take this right here and do the power of a power rule. So this is still negative 2 to the 4th. Remember, when we do power of a power, we multiply the exponents, so it's x to the 2 times 4, or x to the 8th, times y to the 4th, times negative 1, times 2 to the 4th, times, again this is x to the 2 times 4. Now we can combine the ones with the same bases and multiply those. We've got negative 2 to the 4th still, times x to the 8th times x to the 8th. Well, when we have it look like that, that's when we add the exponents. So it's x to the 16th. Our y's can go together. Y to the 4th times y to the 4th. That's where we add the exponents and make it y to the 8th. And then we've got times negative 1 times 2 to the 4th. Okay? Well, now we could rearrange all this stuff, but I can do something else with this yet. Notice how these bases are really close to being the same thing, but they're not quite the same thing. But we can make this so they do end up being the same thing. And here's how we can do that when we've got a negative and a positive. Think of this as two things multiplied together. So think of it as negative 1 times 2 to the 4th power. Okay? Well, we have a rule for this. Remember, this is the same as negative 1 to the 4th times 2 to the 4th. So negative 1 to the 4th times 2 to the 4th times x to the 16th times y to the 8th times negative 1 times 2 to the 4th. Well, now look here. We've got the same bases that we can combine here. This is negative 1 to the 4th times negative 1, which would be to the 1st. Negative 1 to the 4th times negative 1 to the 1st, well, that's negative 1 to the 5th. Times 2 to the 4th times 2 to the 4th. That's where we had the exponents. It's 2 to the 8th. Times x to the 16th times y to the 8th. And that is as far as we can possibly simplify that problem. We have no other bases that are the same. A lot of work for that problem involved. Okay, and let's go on to one last slide. Okay, I want to go ahead and look back at this here and see again how these things can be different. Okay, so negative 2w squared. In this instance, okay, what we're going to do with this is take the two things we're multiplying. Take the two things we're multiplying in here and raise them each to this power. So this is negative 2 squared w squared. Okay? Well, this one over here, this is different. This is negative 1 times 2w squared. So in this case, the only things that the exponent applies to are this stuff in the parentheses. This is 2 squared w squared. So this one is negative 1 times 2 squared w squared. Okay, so now that we got this one broken all the way down, let's look at how this is different than this one. Remember what we said before on the previous slide, that we can break this down further yet and say this is the same as negative 1 times 2 squared w squared. Then we need to apply the exponent to both of these, so it's negative 1 squared 2 squared w squared. So see how these two things are different from each other because of where the negative sign is located. Okay? Basically, if I multiplied all these out, this could simplify to negative 1 times 4, which is negative 4w squared, whereas this one would simplify to negative 1 squared is 1, and 1 times 2 squared is positive 4w squared. So these would simplify down to different things. Okay, so it's very important to recognize where the negative sign is located affects the problem. Alright, and that's all we got for you for this lesson. Good luck on the homework.